So let's talk a little bit more about what do you need to do to get ready for the deployment. So there's obviously a clear life cycle of what's going to happen with Azure Stack between you're thinking about buying one, you order one, you answer the questions to help it get it configured, it gets shipped to you, and then it gets deployed on site. So we're going to drill down a fair amount into what you have to do to prepare for an individual Azure Stack deployment. So if you think about the parties that are involved here, there's a customer, there's got to be a hardware partner, and Microsoft is providing the software and guidance on top of it. They're involved in different phases of this journey, which should be fairly obvious. So the thing we're going to focus in on a lot is collecting this deployment information. So there are a number of questions. It's not a gigantic number, but they're important questions that you need to provide data for, and that data will feed and drive the deployment of the Azure Stack Scale Unit. So once the hardware arrives on site, that information that was collected in the deployment information ahead of time will be used to drive it, and it will perform an automated install of the hardware. So during the on-site deployment, what should happen? So the first thing is it's worth double checking all those questions that the customer answered in the spreadsheet or in the deployment information. If they get some of the fundamental things wrong, as some of the customers that you've visited, they might decide to redeploy later, which is going to be painful. And some of those fundamental questions, it's worth making sure. Say, are you really sure you want to do this? So we think that the most flexible deployment of Azure Stack would be you use Azure Active Directory as your directory, so your users are going to come from there, not from your own Active Directory on premises. And we think that you should be connected, not disconnected. There are obviously very valid reasons for being disconnected or for not using Azure AD, but we have had customers that regret thinking, oh, I'm special, I need to be disconnected. I don't want to use your directory, I want to use my Active Directory, and come to regret it and redeploy later.
Yeah, the point I use from this, and it comes from our experience as well as working with just domain structures and building forests. You should build a single domain forest, but everybody replicated what they did in the old NT domain models, just because that's what they were used to, and they regret those decisions. So I would strongly, like Pat said, double that effort to say, you should use Azure Active Directory and you should be connected, and let people talk you off of those points, as opposed to going, oh, we can do either one, you pick, because they will almost always, history tells me, pick the wrong one, right? I had a customer just recently, we were talking about it again, that not only did they decide to go to ADFS connected, but they built a completely separate forest because they thought they were going to be in a secure environment that had no user accounts. So it's not even connected to their Azure or their AD on premises and the user accounts. They had an empty forest. Like, just the absolute worst conditions. And so guess what? It's a redeployment for them.
And then they wondered why their users couldn't access it.
Yeah, no one could log on to the Scale Unit.
They had no users.
Because there were no users. But it's ADFS connected. Yeah, but to an empty forest, right? So this is where I go back to, I said, a huge opportunity for any consulting group or partner group that wants to be in part of this is work that is weeks worth of getting down and explaining to the customer. Just don't ask them the question. Because if you ask them the question, ADFS joined or Active Directory, they're going to go, or Azure Active Directory, ADFS, all right? Roll the dice. Explain what the impact is and what the cost is and what the benefits of all of this is, so that they can make an informed decision.
So the second point up here is, at some deployments, we found that there are data centers and they don't let vendors into the data center, right? So that's obviously a problem for Azure Stack. It's not like that organization can buy the hardware and do the deployment themselves. So make sure that you have either accessibility to the data center or at least a way to connect in remotely and do the deployment. Once the equipment shows up, it will be racked, or the rack will be rolled in. Normally it comes pre-racked, but there are some options to buy an Azure Stack and fit it into an existing rack. That's OEM specific. You'll connect up to the border devices, so to the routing infrastructure inside the environment. We'll prepare the hardware lifecycle host, so that's that extra bonus small server that's sitting in the rack on almost all the vendors' deployments. And there's like a lights on check, so it's making sure that the Baseboard management controller is updated. All the firmware and all the devices are at the right level. All of the hard disks spin up. There's no failures. Nothing bad is broken in shipment, etc. And then we'll kick off the software deployment itself. So that's a sort of a rough schedule of what happens on the hardware front. Once the software installation is kicked off, there are some sub-phases in here. So it will install the latest updates to Azure Stack. So that's executing one of these patch and update cycles. You can test the consistency and the setup of the Azure Stack after the deployment's finished. And then you will register it with an Azure subscription. More on that in a little bit. And then you get given the Azure Stack scale unit. So that's a handoff. OEM deployment is finished. All that stuff is done.
So just a couple of points. I know we got some hardware vendors in here, so you'll hear what we're telling our customers, but I'll maybe ask for some input from you. This is done by the hardware vendor, and they're going to be taking your input and running it into their stamp, their script that customizes it. One of the things they're going to ask you is, what is the administrator account names and passwords? So they're going to put that in their script and they're going to run it. So guess what happens when they leave? What do they know? The script is still there, and they know your administrator usernames and passwords. So what should you be doing shortly after your vendor leaves? Reset those passwords. You know, there's things that you should do. Now, the vast majority of our vendors are very good at a bunch of the stuff that they're supposed to do here. One of the things, there's a thing called a DVM, a deployment virtual machine, that is part of there, that has root access to all the nodes. They're supposed to remove that DVM to remove the vulnerability. I was at one deployment that wasn't done. So part of what we'll have you do is to go through some of these security checks that once the vendor leaves, it becomes yours to run, and you need to provide some of those customizations. They are there to provide the base deployment of that scale unit. The hardware vendors, you can please speak up. They are going to deploy the version of Azure Stack that is on their current supported list. So one of the vendors, we just released 1901. So we deployed 2.5 weeks ago 1811. Because, and they said, even if it was deployed today, they would still deploy 1811 because that's part of their stamp script, and it was up to them to either upgrade or not, and it was part of their service level agreement or not to do that, because it could be a long upgrade. It could be 36 hours to go from an 1811 to a 1901 upgrade. So who's doing that? Is that my vendor, or is that me that's going to be responsible for that? So they will deploy to you the most recent version that they support in their deployment of their scale units. So little things along those. Is that the same for, so as soon as 1901 is, you're not deploying 1901, right? You have a process to go through and vet for your stamps, right? So those are the kind of things you want to be careful about.
So the next thing to think about is, do you have the right capacity for your Azure Stack? So as Robert mentioned below, there's a capacity planning tool. So it's a spreadsheet. And you plug in a bunch of information about the workloads that you expect to run in your Azure Stack. So this is really an end customer activity, but they can for sure be helped through it. And then the type of hardware that you expect to buy. So once you populate all that information, it will tell you how much capacity you require to purchase in your Azure Stack. And it takes into account that patch and update one server node reserve, and it takes into account how much capacity the fabric virtual machines, the things
core,
that are running.
Yeah, the IaaS core ones, yeah, not the PaaS. And
Right, true, yeah, so yeah, let's come back, we'll talk about that later. So all the virtual machines that are there running the core fabric of Azure Stack, how much resources they consume. We'll talk about it a little bit later, but the most precious resource in Azure Stack, the thing that does not get overcommitted, is memory. So every virtual machine that gets spun up, whether it's part of the fabric or whether it's a user workload VM, has a committed amount of memory, and that amount of memory is taken out of the system right away. It's always used. The other computing resources, so CPU, disk to some degree, and network bandwidth, those can all be overcommitted, right? So if I create a virtual machine with 1 gigabyte of memory assigned to it and 1 CPU, you're going to get 1 gigabyte of memory, but you might not get 1 full CPU power, right? You might get a fractional CPU power if your system is quite loaded. So that's really what predicates, that's what drives the capacity in the capacity planning tool, is how much memory is going to be consumed by all the things that you want to run on top of Azure Stack and Azure Stack itself. So what are the prerequisites for Azure Stack? What questions are you going to be asked? So one of the fundamental ones is, how do you want to pay for Azure Stack? So obviously, most of the things that you pay for in Azure Stack are on the purchase of the hardware. You're going to pay for your HVAC. You're going to pay for the operational skills, etc. If you buy an Azure Stack and put it in your data center and never put any guest workloads on it, the software is free. Now,
If you go to capacity.
Yeah. Now, you have to make a choice. You can choose to pay as you go, which is the consumption model, which means that meters inside Azure Stack are sent up periodically up to Azure, to our billing service, and they measure how much guest capacity is running, how many virtual machines are running, how many websites have you created, those sorts of things. And they are billed on just like a regular per hour basis, just like you would if you fired up the same thing in Azure. The bill rate for Azure Stack for a VM is cheaper than it is in Azure, far cheaper, because Microsoft isn't paying for the hardware, we're not operating it, none of that business. So the per hour rate of a VM is only a small percentage of what it is in real Azure. So if you choose the consumption model, which is the most common model, you will only pay as user workloads are deployed, and you'll only pay for however long they are spun up. So you can spin them down at night, you don't get charged for them. The other model is a capacity model. So in the capacity model, you're saying, I have an Azure Stack that's this big, it can run about this many guest VMs. I'm going to pay per month as if I'm fully loading it up. So you can just say, I'm going to pay you a flat monthly fee to Microsoft. You get billed per month. So you get billed per month, a flat rate, and it assumes that you're fully using that Azure Stack, more or less. That you sign that up on a year-by-year basis, and really the reason for that capacity model is because some people want to run disconnected. So obviously, if you're disconnected, you can't send the meters of what's running up to Microsoft, to the Azure billing engine, so you're just going to have to pay on a monthly charge.
Is there a discount associated with capacity, like a reserve instance kind of thing? Or?
Yes, yeah. It roughly takes into account how many guest virtual machines could you run and charges you for that.
Yeah, so capacity is, there's two billing models. It's just based on the number of cores, but based on the workload. Is it IaaS? I think it's $400 per core. And if you go to PaaS services, it's $144. So it takes into account of kind of what the workloads. Oh, it's the other way around. Sorry, yeah. I don't get paid to sell, right? So there's a fee based around how you're going to use it.
So these two billing models, the capacity model, although you can sign up for it if you are connected, it doesn't make much sense.
Yeah.
So this should be the default position going in. Everyone should use consumption unless they're disconnected.
Yeah.
Hardware costs are rolled with this, or there's
Hardware costs, no. So the question is hardware costs.
you buy your physical.
Yep.
You buy the hardware.
This is the software license.
Correct. Yeah.
Making sure I was thinking if you guys somehow rolled the
Nope.
hardware costs into the payment.
No.
Right?
Yeah. No,
Now,
this is only
and
software.
While we are vendor agnostic, we love all our hardware partners. Each hardware partner has a value proposition that is unique to them. So find something that is going to be, because we've got some hardware vendors that might say, we'll bill you for a 4-node, but we're going to ship you a 6-node, and we're going to monitor capacity. And if you ever go above that capacity, we're going to bill you for the extra nodes that you're working with. Like, they're all fine.
They've all built service offerings. They may have service offerings.
Yeah, and each one of them has a value proposition that might appeal to you. So.
There's even ones that are scaled like for AI or intense compute.
That's more, so we're talking about the disk subsystem.
Yeah.
Just the disk,
But
not a stack specific.
find a vendor and build a relationship with them. This is something that is very important, I believe, for you to make sure you're getting that relationship with your vendor. This is a decision that you can change.
Yeah,
This
we'll-
is not a redeployment. We're going to talk
we'll
about that.
come back to that.
But
We have a good list.
we don't. If you buy capacity, you don't get the money back. Oh, I changed my model. So once you got to wait the year, kind of, you can switch it, but then you're still going to be paying a bit extra.
So that's the fundamental question. So when the information is collected from the customer, previously we used to have a spreadsheet with a whole bunch of macros in it. Now there's a PowerShell-based GUI tool that can collect all the information. Ultimately, this information just gets piped out into a file, a JSON formatted text file, and that text file is used as a parameter when doing the deployment. So just a quick run through of what the PowerShell UI looks like. It's asking all the same questions as it did before. It's available directly to customers, although the OEMs can customize it because they might want to ask some additional questions just to satisfy configuration items that might be specific to them. And you can basically open a configuration file that was previously created, edit it, and you can export it again. It's also backwards compatible. You can take a output from the spreadsheet and suck it up into the PowerShell UI. So it looks like this. It's going to ask you a bunch of questions. What do you want to use for your identity? What's your company name? What's your domain name that you want to use? What are the prefixes for the virtual machines? Where's your time server? So it's going to ask a lot of these questions, all of which feed the initial configuration of Azure Stack. Once you've entered all the information, you can use the menu to generate the output file. As I said, that's just a JSON file, and that JSON file will be used to drive the deployment. You'll be given that by the OEM as well to set aside saying, hey, here's the JSON that was used to build this Azure Stack environment. And we'll talk about tomorrow, if you ever need to redeploy your Azure Stack, you can go back to that set of information and use it to rebuild it, answering the questions exactly the same way as you did before. You can see there's a lot of detail in the IP address section of the information that you gather. So here's a whole bunch of information about the VLANs, the IP address networks, etc., that you need to specify before configuring Azure Stack.
And to our vendors, if you get this file given to you by a customer, question them on it. Why did you pick this? Just don't take them their numbers, because they might have just arbitrarily filled this out not knowing what the repercussions were. So just don't take the file from them, question them on it. Why did you pick this? Why did you have this? Have you thought about this? So if you just grab that file, it's going to not go too well for you. And for the customers, if they come up and say, here's, answer these questions and we're just going to run the script, again, not the right way to do this. I've got some examples. So the customer knew all the limitations. They had 2 regions that they needed to build. This is a separate company. But they had an IP addressing scheme that they wanted for public IP addresses. And they were going to use, they had 16 ranges, and they were going to eventually have a range per scale unit that they were working with. But they had the spreadsheet, 10.1, 10.2, 10. Pretend it's a public IP address. And so the first one they put 10.1, and the second one they put 10.2. But they were going to be in 2 different regions. One was going to go to the Far East, one was going to be North America. What they wanted was 10.1 to 10.5 for North America and 10.6 to be the other region. But this is one of the decisions. Once you've done it, it's a redeployment. So if you didn't ask those questions about hey, here's my public IP addresses I want to use, you can't change it after the fact. And they kind of went, okay, we now have to throw that concept away of, we can tell whether it came from a North American public IP address because it would have been in this range. It now became this random pick from a list of addresses that would just get assigned to any scale unit, right? Little things along the way that you don't think have a big intention or a big impact, that's part of the pre-planning you want to take a look at. That make sense to everybody? You understand why?
So we're going to talk about integrating the Azure Stack into your data center. So here's a number of common touch points with the data center. Obviously, the IP address space is critically important because you're going to be connecting up the top of rack switches into the data center network. The uplink to your border routers, rules for firewall, whether you want to use Azure Active Directory or Active Directory on premises through ADFS. You need a whack load of certificates to run all the services inside of Azure Stack, and you'll need even more to run websites and other external services. So that's a point where a lot of the early deployments fell down, was they didn't have the correct certificates, or they didn't have the subject alt name with a wildcard in it in the certificates, and that basically caused the installation of Azure Stack to not be able to proceed. And the customer then has to go back and get the right certificates.
Do those need to be trusted, or can they be self-signed?
You can do either. So you can use public certificates. You can use certificates issued by an internal CA inside your organization, which you'd obviously do if you were disconnected. And there are also some self-signed certificates used under the covers inside the box. One thing I don't think we mentioned on the other slide is you need to be able to resolve the certificate revocation list for those certificates. So if you have a partially connected Azure Stack, which means you've gone for the connected model, but it's not always connected to the internet, you should probably elect to use certificates issued by something that's going to be in the disconnected state. Yeah.
Or have revocation lists that are at 1/2 more than what your disconnected time frame is going to be. So I'll go back to my boats. They're disconnected for a week at a time. So as long as the certificates are not going to, fail within that time.
Yeah. You're obviously going to want to integrate with DNS in your data center and potentially with public DNS names. And time, like in all server environments, time is critical within the fabric of the Azure Stack environment. So connecting to an external authoritative time source is one of the questions that will be asked.
Do you have that set up on your top of rack?
The time service itself?
Yeah. Yeah, it can. You can go to a private time server as long as, but it becomes the arbiter.
You're asking literally, can you run the NTP time service on that top of rack switch device?
The BMC or the top of rack?
Yeah. I think not, because if you get an update, don't forget that when you get an update, the settings on those top of rack switches might be updated as well. So you might blow away your own configuration. So normally with things like that, somebody might say, oh, I want to put some router ACLs on my top of rack switch. We say, no, don't do that, because they might get blown away in an update. You can put them
Above
the next
that,
level beyond in your border device. So I think the same thing would be true for NTP. I don't know, but I'm pretty sure.
That's fair.
Yeah, so most people just point it to whatever is the authoritative source in their data center, or if they're disconnected, they might have a time server running just outside of Azure Stack. The 3 things in the blue box are integration points to other systems in your data center that you would do after deployment. So, hey, where do I want to send my events? So I have a syslog server in my environment. I'd like to have the events emitted from Azure Stack go there. That's not configured as one of the questions in the prerequisite list. It will be configured as an additional activity beyond deployment. So all 3 of those areas down in the blue box are places that add-on services make sense. Hey, how do I get this thing nicely integrated into my existing monitoring and management systems? There are a number of port requirements. So we don't go into a lot of detail in these sessions about how the software-defined networking works, but there's a lot of communication that will just flow between VMs and between nodes inside the Azure Stack system. But there's obviously a lot that has to go out and connect to services outside of Azure Stack, particularly on the internet if you're in a connected mode. So this is just sort of a logical diagram of what's deployed. You'll notice that in the top of rack switches, there is a fairly detailed set of configuration items to make sure that the traffic only goes to the right place, right? So there are router-based ACLs in here to make sure that only the right kind of traffic is emitted or allowed entry into the Azure Stack, and all the internal traffic stays internal. Once you get outside the scale unit of Azure Stack to the border device or to any firewalls that might exist in the customer environments, there are various holes that you must or may want to poke through. One thing that's a blocker for some customers is that Azure Stack needs to talk to the internet, to talk to some services. Particularly, the first thing that you're going to need to do to talk to the internet is connect up to register Azure Stack or connect up to Azure Active Directory. If the organization, if the network that you're connecting to requires all traffic to go out through a proxy, and it's not a transparent proxy, like you have to configure it in your browser to get out to the internet, that's not going to work today with Azure Stack. So Azure Stack doesn't have any idea of how to configure an explicit proxy to say, hey, when I go to the internet, I want to send traffic here first, and he'll send it out on my behalf. So for Azure Stack, you need to have a transparent proxy. In other words, just something inline on the network. Question?
We can put it here. Let's say we've got an express route.
Yep.
Set up right. Can we leverage the VNet service endpoints so that we don't have to connect directly to the internet?
Yeah, so I'll just repeat the question. So if the data center you're deploying it into has express route connectivity to Azure, can you piggyback on top of that to avoid having to go out through the regular route to the internet? The answer is yes. It's important to know that ExpressRoute is not a service inside Azure Stack. So what you have to do is you jump out onto the data center network and you have a routing path that goes to ExpressRoute.
Yeah.
Totally get that, right?
Yeah.
But we
But
can't-
that's doable, yes.
Okay, so we can't, so going an express route here to Azure Public, we're good.
Yes, yeah.
Awesome.
For the services in Azure Stack, you might have some workloads running in here that is not good for, but yeah, for just basic Azure Stack functioning, that should be fine. We know this is a problem because we know there are a lot of organizations that do not have a transparent proxy. So there is a private preview now of an Azure Stack configuration that will allow a explicit proxy to be set. And if you imagine it as basically pushing the setting for that proxy into all the VMs that need to talk on the internet so that they know where to go to send the traffic. So we're addressing that problem. It's just not in the public Azure Stack version yet. So there's a few ways to deploy Azure Stack. So there's an edge deployment, which is deployed in a DMZ or DMZ if you're from Canada. And normally we recommend that you put a firewall outside of Azure Stack. It's not mandatory, but obviously if you want to do normal high functioning firewall stuff like detecting DDoS or those sorts of things, you might want to deploy that firewall outside. And there's a very well-defined set of connectivity that's required for Azure Stack, and you would augment that with whatever services, whatever workloads you're running on top, and let that go through your external firewall. We do have ACLs inside the box on the top rack switches, but it still makes sense to deploy an external firewall. So that's a typical DMZ type setup. That's a typical internet-facing setup. You might deploy it on a DMZ that's got a front leg and a back leg. So this is a normal picture of what that would look like. So you might go out into your DMZ network and then out to the internet. So standard enterprise deployment with the DMZ that you're going through. And then I talked about, so that was firewall, traffic, and ports. I talked about certificate requirements. So there's a whole document that says exactly what certificates you need. This table summarizes them. So you can see there's a lot of wildcard certificates. So these you can obtain from public certificate vendor, but you need to make sure that you can get all those certificates and that they're plumbed properly. So there's subject alternative name requirements for a lot of these certificates. These certificates are basically part of the deployment bundle. So you have that JSON file with all your answers. You're going to provide a set of PFX files as well with these certificates cooked into them. And those will just all get sucked up and deployed during the automated installation of Azure Stack. This one down here at the bottom, admin hosting, is relatively new. It's a new service that came in 1811, I think, maybe. We'll talk about that in a sec. That's a way to constrain the number of ports that are required to administer Azure Stack when you connect to it from
27 to 4.
Yeah. So I think we got a good picture for that. So during the deployment gathering, normally the customer provides all this information. The OEMs are going to support the onboarding, although it behooves you to validate that those answers are good. And it includes just the platform deployment. So obviously, if you're deploying platform as a service, services on top of Azure Stack, like websites, functions, SQL, MySQL databases, none of that appears out of the box. That's left to you as an operator to deploy afterwards. So it doesn't ask any questions about those services. But it does include all the networking, storage, naming, directory integration, time service, those sorts of things. So again, here's another screenshot about the basic information that's gathered. So you can see here, these are some critical questions. What's your identity store? You can choose to have your identities for connectivity to Azure Stack come from Azure Active Directory or from an on-premises Active Directory environment through ADFS. We'll talk about connected versus disconnected in a little bit, but that's relevant there. You have to choose a tenant name. So this is going to be the name of your Azure Active Directory that you connect to if you've chosen Azure AD. If you choose ADFS, you have to choose an Active Directory on premises that you're going to point to.
And this goes back to what your earlier question was. When you register to that tenant will get the bill from the 1 or 10 or 50 Azure Stacks you put into it. If they registered 2 different ones, you've got 2 different billing systems.
So yes, you can have multiple Azure Stack clouds today. And they're all set. Reserve it, but don't use it up today.
And remember, public IP addresses that you assign to a scale unit can be added to, but you cannot decrement or take away. So if you add too many to a scale unit, and you went, oh, wow, I gave it 256, and they're only going to have 16 VMs on there, so you can't take them back. The only way you get them back, redeploy. Yeah. So you're better off to put smaller numbers in there and keep adding to them, but then have them logical so that you can go. Those are some of the planning things that you want to be doing up front.
I heard of one case where they picked a public IP address space, and then when they deployed it, they said, oh, God, we've used those IP addresses somewhere else in our data center network.
Yeah.
So that was a bit disappointing. So here are the other things that you need to configure: the time server, the DNS servers, so the DNS queries that are going from services inside Azure Stack out to resolve names in your environment or on the internet need to go somewhere. So you pointed out there, and you've got an option to select a syslog server. So you can automatically configure a syslog server out the box. There's more configuration you can do later, but that's a default one. In the network settings, you can see there's some detailed information that might be OEM specific about like the top of rack switch firmware, those sorts of things. So the OEM would help you answer those questions. Some of those are just for reference. Other ones are used in the JSON file to do the configuration. And then you can see there's slots here for number of scale units and number of nodes in the scale unit. And yeah, that's the same. That's the same screenshot, right? Yeah. So you enter your customer name and your region name, and the prefix. The prefix here is used for the names of the virtual machines that are running as the fabric of Azure Stack. So if you pick CON here, all of the VMs are going to start with the 3-letter CON. So critical decisions you need to make ahead of time: connected or disconnected. I think we've talked about this. If you get this wrong, you cannot change it later, right? So we normally propose that people start that their Azure Stack is going to be connected. Then they can use a bunch of other things. They can use Azure Active Directory as their identity. They can use the pay-as-you-go billing model. If they choose disconnected, they're severely limited in the choices they make. So you cannot undo this one. And just one of your customers you talked to a couple of weeks ago, they made the wrong decision.
Yeah, and this is right from our documentation off of the docs site. And people pick this one because it's the easiest line to follow. When in fact, what you want to try and do is we want you to be connected, and we want you to use Azure AD as the preferred method. It gives you the most flexibility, but you can be connected and still use ADFS and still have the 2 different billing models. So there's a preferred line that we want you to follow through here. But as I said, I had this customer. They said, well, we're going to use this for disaster recovery. So if we have a smoke and hole scenario, we don't have access to Azure. I went, really? Watch this. And so what I did is I took my cell phone, I tethered my laptop to my cell phone, and I showed that I had a VPN back to my Azure Stack scale unit that was completely disconnected. And the Azure Stack doesn't have to be authenticated to Azure. The client does. And so I authenticated through my phone. So I said, in your smoke and hole scenario, what's the chances that Azure is not available to you? It may not be available to the scale unit, but do you have access for it from an authenticator? So these are the decisions, but they made this decision saying, oh, we have a smoke and hole disaster scenario. We have to have a completely standalone, disconnected environment that won't have access to Azure, so we need to be ADFS joined, and I'm going to have this new domain for it because we don't have access to our domain controllers. And so they had this empty forest connected in a disconnected model, and the nightmares it causes them, because now they have a problem, and they open up a support ticket. We're going to cover this tomorrow. To break the glass, you have to give us a key, 128 bits. We have to give you back a key, 128 bits. And the only way that they could transfer it in was they have to write down the 128 bits. They had to come over to the support case, type it into the support window. We ship back to them the support key. They write down the support key. They go into the scale unit. They type it in. Like, they're doing that every day of every week going, wow, I wish I hadn't done that. When in fact, we showed them that there was a better way to get that smoke and hole model of a disaster recovery for them to get it, because they just misunderstood what they thought disconnected meant.
The other conversation I've had a few times is people choose this route to deploy using their on-premises Active Directory because that's what they have today. That if they're not an Azure consuming customer, they don't have an Azure AD set up. So that's, again, that's probably the wrong reason to pick that route, because later on, if you want to build a hybrid application that's got some parts deployed in Azure Stack and some in Azure, it's going to be way easier to do it if you have Azure Active Directory and not an ADFS to your on-premises AD.
It's pretty simple. I mean, as long as they've got AD Connect, synchronizing their users up,
Yeah,
it's
it's,
And I would say, you don't have to have Azure AD to have ADFS. You can still be connected to an empty tenant that has no subscription to hold the space, and then still be running ADFS to run into that. So I would suggest that to the customer is, yeah, you're not in Azure, you're not using Azure AD yet, but just go grab a tenant.
yeah, it's not hard to start, I guess is your point, right? Yeah. Sometimes it's a different team, right? Like sometimes you get people saying, oh, well, I can connect up to my on-premises AD, but I don't even know how to do that.
Yeah.
Okay, so that's the connected or disconnected decision. As I said, if you're disconnected, there are some harsh restrictions. You obviously have to use ADFS, because if you're not connected to the internet, you can't connect to Azure AD. And you must use capacity-based billing, because if you're not connected to the internet, you can't emit the meters up to Azure to form your bill on a monthly basis. So those choices are constrained depending on what model you pick. I think we've been through this, so yeah, you choose between two identity providers. You can choose Azure Active Directory or ADFS. If you're connected, you can choose either. If you're disconnected, you have to use an on-premises Active Directory.
And another constraint that we want to point out at this point is the ability to go multi-tenanted versus single-tenanted. We have a whole conversation, we're going to talk about that. You must be Azure AD joined to go to what's called a multi-tenanted environment. If they wanted to go to ADFS, they could only have all their tenants come from one Active Directory domain environment or forest that they're working with. If they wanted to be able to build back each tenant, so in this case, the IT department was going to manage all the scale units, but they wanted each division to be able to build back to their own Azure subscriptions. The only way that that could happen is if they registered to Azure AD as the scale unit, and then each tenant would register individual tenants to either ADFS or to Azure AD. But the only way they could get that as an option was to register the scale unit to ADFS.
Yeah, there's no option to connect to multiple Active Directory environments. You pick one and you will federate with it. Oh, so that's about the Azure AD connection. So normally people will use the same account for both of these purposes. It's possible that you might have like different administration teams for Azure. So you might use one account to send the billing information up. That's the responsibility of the finance department, let's say. So we're going to use the finance department Azure AD account to do that connectivity. And then there might be a provisioning business unit that's responsible for, hey, I need to create a service account, or I need to create a group in Azure AD. So it's possible to divorce those. I don't know what your experience is, but
Yeah.
most of the customers I talk to, they use the same account to do both the registration and the.
So how do you distinguish between the two
So
capabilities?
a good example of this is there's a built-in engine that's part of the fabric that sends all the billing information up to Azure. But if you imagine if you were a user, you might create an ARM template that said, I need to deploy 2 Linux servers and I need to create a service account in Azure AD. That part the ARM part of the fabric in Azure Stack that would do that activity for you, it's exercising that function because it says, I need to go and create a service account in Azure AD for this application. So you might not want that part of the Azure Stack engine to have the full right to go and do arbitrary stuff. So it's a security separation as well as a functional.
This one is almost like a read-only account. It can only read, but it can only read billing information, where this has a functional role to actually be able to deploy components that you're working with. And we're going to talk about RBAC later, and we have RBAC within here that you can, but this is like a hard RBAC that says if you want to separate those two roles, which would be our recommendation, that you don't want a billing person potentially being able to deploy things or vice versa. So it's a hard line in the RBAC solution as opposed to being RBAC.
Right, I think we've talked about all these disconnected issues on this slide. So you must use ADFS. When you do set up ADFS, you have to use a service account that gives you right into that target Active Directory environment. And you cannot have multi-tenancy. You're only connecting to one Active Directory, so all the users must come from that one Active Directory on premises. And it says some features are impaired or unavailable. So for example, the patch and update cycle looks a lot different if you cannot download those patch and updates directly from the internet.
Support models.
Yeah, support's different. Entering the key is different. Yeah, the other thing we didn't mention that's on this slide is if you're disconnected, you still have to register your Azure Stack because it's going to appear in your bill and you're going to be on the flat rate billing. So there is a process to take the identity of your Azure Stack and push it up into your whatever Azure subscription you want to register it underneath of. So that's this, there's like an offline registration process. There's also an offline patch and update process. And the other critical thing is, we'll talk about the marketplace, but obviously in Azure, there's a whole bunch of items available in the marketplace, and they get refreshed all the time as the vendors update that marketplace offering. So server templates, other software products, etc. In Azure Stack, you have the same thing for a subset of those marketplace items. If you're disconnected, you obviously cannot syndicate. You can't get automatic updates down to your marketplace. There is still an out-of-band way to take marketplace items and push them into your Azure Stack disconnected. Okay, we're going to talk a little bit more about networking. There's a ton to talk about networking, so we're not going to go into excruciating detail, but just keep in mind that there are a number of networks required for the operation of each Azure Stack. Some of the functions have to have public-facing IP addresses. In other words, they have to be internet accessible so that they can go out and talk to things outside of Azure Stack. There are a number of networks that are just used for communication between server nodes, both for storage. So you can imagine, because the disks are locally attached onto each server node, but accessible from all the servers, there's tons and tons of storage traffic that has to go between the nodes. So if I'm server number 4 and I want to access content on a disk that's on server number 1, I've got to go across the network to grab it. So that's all handled under the covers, but those networks are deployed so that the traffic is only visible between the nodes inside the Azure Stack. It never goes public. So here's just a quick summary. So there's a public set of IP addresses. Some of them are used for endpoints that are part of Azure Stack itself, and then the rest of them you can use for user workloads that are running in Azure Stack.
Can those be natted?
So yes, you can use a private IP address in your public IP address space, right? So you might have a 10 dot address as your public VIP, and then do NAT external to Azure Stack, right? Yeah, so there's no natting right inside Azure Stack, but you could NAT it outside.
So that public VIP is...
It's public facing and not necessarily a public RFC address.
Yeah, so if you have a tenant workload that builds a website that needs a public face, it pulls from this public IP address pool that they then have. And we're going to show you later on how to create quotas so you can limit that down, so how many you're going to get versus how many you're going to get.
That could be a 10.
Could be natted out to the internet, yeah. Obviously, you've got to take care of the natting yourself then, but it's perfectly possible. So I'm not going to dwell on any of these. There's a There's infrastructure services. There are a storage network that goes across the private network, and this baseboard management controller network is used by that BMC server, the hardware lifecycle host to talk to the BMC components on all the server nodes and the switch. So another way of showing that picture, here's the size of the subnets you need. So you need a fair number of IP addresses. The ones that are internal only, obviously they never appear on your data center network, so you can reuse them from one stack to another, but they're used to provide virtual IP addresses to all the fabric VMs inside your environment. The public VIP, it's got a relatively large network. It's advertised as a set of individual /32 networks. And you can increment this over time. So the main idea is to just pick the smallest size as you deploy your Azure Stack, but make sure that if you're going to be adding workloads onto it that are going to consume public IP addresses, that you have space to increase that. Right? So don't put it off in a corner of your address range that you're going to regret later because it's going to cause you routing configuration pain.
It has to increase sequentially, right? Can't jump or take different segments.
No, you can take different. They can be discontiguous.
Yeah, as long as you have public IP address space left. But for routing, you normally want to have them adjacent to each other, right?
It goes back to the scenario I gave you. Is they gave it a great big address range, and then they gave the next one, and they went, oh, rats! We no longer have this contiguous range that these ones are going to get this range. Now I have to manage. Oh, this one's got this one, and then skip some, and then this one. You want to think about that before you deploy your first one, and think about what it's going to look like long term.
So we got a few pictures like this that just sort of break down the traffic. So here's some of the internal networks. So we have a storage network that's used primarily for storage spaces direct traffic. And we also use it to migrate virtual machines from one server node to another in the event that they have to be repositioned, maybe for patching and update. And then we have an infrastructure network, which is the main network on which the fabric VMs of Azure Stack talk to each other. So again, this is all just so you can understand what's under the covers. There's no real need to ever administer these IP address ranges or do anything to them. Once your Azure Stack is built, these are all set up. They're all plumbed into the virtual machines. There's also the BMC Network Connectivity. So you know from the original picture that there's a BMC switch. It's responsible to talk to all those server management, switch management ports on the network, and they'll all be wired in for you as part of your Azure Stack deployment. So they can be used for like out-of-band management of the servers, et cetera. So it's got its own dedicated network and its own dedicated subnet assigned as part of the choices you make in the prerequisite spreadsheet. The public IP network, I think we've talked about everything on here. So it starts with a certain range. You can expand that as you need more public IP addresses to support user workloads. And they're all plumbed up to the top rack switches, and then they're allowed to send traffic out to the border device and onto the internet. We talked about routing outside the top of the Azure Stack. So the default way to provide routing into the data center network and ultimately out to the internet is to use Border Gateway Protocol. There are a bunch of questions in that deployment UI about what ASN numbers you want to assign to this Azure Stack instance. So you'll get that from the networking team of your customer, and you say, hey, I'm going to introduce a new device into your BGP network. Can you give me some numbers? That hopefully they'll easily assign you some, and then when you connect up your Azure Stack scale unit, it will automatically be able to route out through the border devices to wherever it needs to go. So you need to answer a few questions about that environment. It is possible to do static routing. So if your customer network does not have BGP implemented as a routing protocol in their data center, you can define static routes. And that's basically just saying, hey, in your router, you're going to identify Azure Stack as having this address space. And in my top of rack switches, I'm going to identify all of your data center address space and all the internet as connectivity that should flow out of Azure Stack. So it's obviously extra manual configuration there, but possible if there's no BGP in the environment. We talked about the time server. So all of the fabric virtual machines all of the server host nodes will go and get time from whatever IP address you specify. And you can also pick a syslog server to send logs from the Azure Stack system out to an existing syslog server on the network. Those holes are already prefabricated out through the router ACL in the top of rack. So all you need to do is enter them in the configuration spreadsheet and it will start syncing time and sending logs to the syslog server. So integration into the data center. We've talked about all the things, the questions that you answer during the pre-deployment information gathering. There's obviously a lot more things that you might want to integrate to in an existing data center. So from the base hardware level things of connecting up to power, cooling, etc. You've chosen your identity integration, whether you're connecting to an on-premises Active Directory or up to Azure AD. And then these things, monitoring, ticketing, ITSM processes, hardware monitoring, there might be existing solutions in the data center that you want to reuse.
You do this long enough, you never get surprised by things. At the base of each of the scale units, there's a thing called a PDU, Power Distribution Unit, that redundantly connects power up to. And I had a customer that thought that was their power backup. They thought that if you pulled this switch out of the scale unit would still run. Like, no, it's not battery backup. It's just a power distribution component. Like, you want power backup, you got to plug that into a point that has enough power and enough power backup to draw the capacity that you're looking for. Again, I asked the question, they said, oh yeah, we got that planned. Okay, but you're gonna add some more nodes. Have you planned for those more nodes? No. So what you thought was gonna give you an hour's worth of capacity, you double the number of nodes, you're now at half that capacity, right? So all these kind of questions that you run into that people just don't think about, you get to play Microsoft, going back, you gotta pretend all those things that you gotta do to provide that, capacity and that survivability of the scale unit itself. That's your responsibility.
So yeah, so there's plenty of work to be done in this space about integrating into existing systems in the customer data center. That was nothing standard out of the box. That would just be something to discuss with your customers and figure out how you can help them integrate with whatever they've got. OpenView, monitoring systems, ticketing, alerting, etc. We'll talk about some of those things tomorrow when we talk about monitoring Azure Stack, but lots of space to have discussions with customers there. Here's a little exploded diagram of how you will be connecting the top of rack switches up to the border devices, the BGP routers in the environment. So you can see they're cross-connected. So you can afford to lose either of those border devices. You can afford to lose either of those top of rack switches, and there will still be a path for all the nodes, all the VMs to talk out to the network.
And just because I had a question at one of the breaks, remember, if I had another node, we had a layer in here for the aggregate switches that then aggregate the communication between the two nodes that then would then need to be redundantly connected to your border switches. Yeah,
ultimately, when we get multiple scale units in one region, those TORs will be cross-connected to some aggregate switches between the two racks. I mentioned you can do static routing if need be. Otherwise, you will answer some questions about your BGP network in the information gathering exercise, and they'll just be automatically plumbed into the top rack switches during the deployment. So you can see that the software deployment of Azure Stack isn't just putting the software onto the Windows servers, it's also configuring software in the network switches. It's putting on those ACLs based on the IP address ranges you gave. It's configuring the BGP networking based on the ASN numbers that you've given, etc.
Doesn't this network configuration here go against what AWS does for their network? Or say Microsoft itself, isn't it more of a meshed configuration on the networking side?
Like inside the data center? So
Inside the data center.
yeah, so yes, so today there's only one scale unit in one region in one cloud. So it's all just going out. Yeah, but you're right. Once we go to multiple scale units in a region or multiple regions in a cloud, then there's going to have to be consideration about, we don't want the traffic bouncing way out the top and coming all the way back in. It'll go through the aggregate switches.
And you want to start thinking about that growing, because in the TORs from each of the vendors, I believe that the options you're given is, do you want a 10 megabit or a 40 megabits port? And they're not expensive, or it's cheap, so they're expensive. So people go, just give me a 10 megabit one.
Hopefully
Well,
gigabit. But
Yeah, or gigabit. Yeah. Now you've restricted your connections across all of them. So what is your future capacity that you're looking for? Because you might have to spend some money up front to get the 40 gigabit.
I mentioned that there's DNS integration. So one of the questions you answer in the pre-deployment information is about what's your external DNS server. So that's provided, and secretly under the covers in the fabric of Azure Stack, there's a whole Active Directory environment. So there's domain controllers in there. All the fabric VMs are joined to that Active Directory, and we use it for service accounts and that sort of stuff. So there's also an internal DNS server that's part of that invisible Active Directory that's part of the fabric. So when you enter the IP address information for DNS external, it's basically configuring the internal DNS to say, hey, if I can't answer this question about names,
Forwarding.
who am I going to send it to? So by default, that internal DNS environment that's part of the fabric of Azure Stack will just forward out to the IP addresses that you've given it on your regular corporate DNS network. And then you're responsible for forwarding that wherever you go to. So that's set up at deployment time.
Had a customer that answered it at 88888.
Because
Got
that was what was
deployed.
in the
Yeah, that's what
example.
they were used to. And
Then
sure
they
enough,
wondered
the
why they
network
couldn't
guys,
resolve any names.
so it couldn't resolve any names externally, right?
Yeah.
It's-
Luckily, that is changeable
That's
afterwards.
changeable, yeah.
So we'll have a good table just after lunch about what you can change and what you can't change after deployment. So here's just a little table. We won't go into details. It's what traffic goes inbound and outbound out the top of the Azure Stack network.
So these are the IP addresses that have to be unique.
Correct.
Per scale unit.
All the other ones on that first one can be.
Yeah, they could.
Repeated multiple times.
So a couple of models for internet connectivity. We talked about the proxy must be a transparent proxy. This will explode that out a little bit. So here you are directly connected to the internet. That's obviously pretty obvious. The red parts are the beyond Azure Stack, and the blue is inside Azure Stack. If you have a transparent proxy, so a proxy server that's just intercepting the traffic as it routes across your network, it would naturally sit somewhere in there between you and the firewall, and you wouldn't really notice it's there. So that's a nice, happy path for Azure Stack. What we've seen some customers do with that transparent proxy is they might have a non-transparent proxy, and they just insert some routes that say, hey, when you're sending your traffic, you'd better route it through this transparent proxy. It's got rules in there that says, I'm going to forward it over to the real proxy that everybody else in the environment is using, and then it will go out through the regular proxy around the houses. So this is obviously a network topology change that would need to be made in the customer environment just to get around the fact that that non-transparent proxy over there, we can't configure it in Azure Stack yet. As I said, private preview is available to select customers to let them configure Azure Stack to know about that non-transparent proxy and send traffic there. So I expect that to become a mainstream feature within the next couple of releases.